Here we go. Here is Champ's version of how to do the math problems. All right. So I've got 3 examples up here ready to go. And I've got the things I grade over on the side. Now you'll notice they're exactly the same as they were before, with one exception. We've kind of highlighted there's a 1b this time that I'll get to here in a second. So the equation, write the equation. So the equation for acceleration is equal to change in velocity over time. Okay. Now, if you remember, so this symbol right there means change in. So if I write change in velocity, that means change in velocity. That's how you would read that. Now, the change in velocity is simply how much the velocity changes. To do that, you just subtract. So you just take the final velocity and you subtract the initial velocity. So that's all it is. So some people like to do this step before they do any other plugging. Some people like to do it all at once. So in this case, if we're looking here in example 1, an object is dropped 3 seconds, and 3 seconds later, it is traveling 29.4 meters per second. What is the acceleration? What was the acceleration caused by gravity? All right, so if you wanted to calculate the change in velocity first, you'd take the final velocity, and I wouldn't make you show all this work, but you can if you want to. 29.4 is the final is 29.4, so it'd be 29.4, and you'd be subtracting what it started. Now, it doesn't come out right and say, but if you drop something, it's going to start from rest. So it'd be 29.4 minus 0, and so the change in velocity is 29.4. Now, that's if you want to do it that way. Now, some people like to do it that way first, and then they just take this and plug it straight in for the change in velocity. Some people like to use this version of the equation, and it's totally fine if you want to do it this way. They just do it all in one step. So instead of calculating this first, they just put the final velocity in first as 29.4, subtract 0. Notice you end up with the same thing. Now, the units here are important, so let's make sure we put some units on here. The units would be, and I'm running out of room, so we're going to move. The units here would be meters per second, and then we would divide by 3 seconds, okay? When you punch that into the calculator, 29.4 minus 0, hit enter, then divide by 3, you get 9.8, okay? Now, we need to talk about the units, all right? And the units are very important here. So what you get here is the units in here shows meters per second per second. Now you might think that the seconds cancel. So you might think that that happens. That doesn't. That would give you a distance. And actually mathematically, that doesn't actually happen. This is equal to meters per second divided by seconds, which, as you know, whenever you're dividing fractions, you multiply by the inverse or multiply by the reciprocal. You actually get this. And what you end up with is meters per second squared, okay? Now, it is perfectly fine to leave your units like meters per second per second. What this is saying is that the object is going that many meters per second faster each second, okay? So if we come back to our equation here, or our answer, our work, it'd be meters per second, or if you wanted to, meters per second squared would be just fine. Okay, so that's how you would do the first one. Okay, let's try this second one right here. A car accelerates from rest at 15 kilometers per hour per second. How long will it take to reach a speed of 55 kilometers per hour? So here is another situation where you've got to either rearrange the equation, right? So you can take this and you can multiply both sides by t, and this is how I recommend you do it. Multiply by t, and so now then you would divide each side by a, divide by a, and you end up with t is equal to the change in velocity over a, right? That's how I would recommend you do it. The other way to do it is just to use the equation that we used up above, A equals delta V over T, and just put in X for T and solve for X. So if you want to do it that way, that's fine. I prefer to do it this way. Now I'm just going to do it this way. Now, if you wanted to find the change in velocity first before doing all this, that would be okay. There's my equation. Let's plug in. So we're from rest to a speed of 55. So my final velocity is 55 kilometers per hour minus 0 over the acceleration here, which is 15 kilometers per hour per second. This time the kilometers and the hours will cancel. And I can show you the math there if you want, or you can believe me. I'm going to have you just believe me for this point. All right, so now it's just 55 divided by 15. And in my head, I think this comes out to be 3.67 seconds. I'm going to run this through a calculator to double check. So hold on a second here to get the calculator going. 55 divided by 15. Yep, 3.6. It's actually 3.6 repeating, so 3.67 because we're going to round that. Okay. All right. Finally, we've got number 3. All right. Now this one kind of varies on how you want to do this one. A person running from rest accelerates at 5.43 meters per second for 3.2 seconds. How fast is he or she going? So now we're solving for the final velocity. How fast are you finally going? Now, on this one, you can't calculate a change in velocity first. We're going to have to do that after because they're asking for how fast it's going. So you can really do this 2 different ways, and it really depends on which way you want to do it. Okay. So the first way is just to use the equation, all right, V final minus V naught, or that's initial, equals T. And then what we're going to do is we're just going to solve for that, okay? Now, starting from rest means that this V0 is 0, so we don't have to worry about that. So now it's just a matter of making sure our algebra is good. So it'd be 5.43, and again, I'm going to use my units in my work because it helps, equals VF over 3.2 seconds. So I'm going to solve for VF. Multiply by 3.2 seconds, slash die, multiply this side by 3.2 seconds, kill one of the seconds, and look what's left alive is a meters per second. Well, that's a how fast. So now it's just 3.2 times 5.43. And I get a final velocity of 17.4 meters per second. Okay. Now that's one way to do it. There's another way to do it. And the other way to do it would be to do it this way. And so I'm just going to erase all what I did right there. And you can hear my 1-year-old in the background is trying very hard to be supportive of what I'm doing here. All right. And so here's how we would do this a different way. All right. Is I would just write the equation like this. And either way here is fine. And what I would do is I would solve for the change in velocity. All right. So to solve for the change in velocity, we would just do change in velocity over T times T times T. And what we end up with is the change in velocity is equal to A times T. Notice that's pretty much exactly what we got when we did it the other way. Either way here works. Now we just plug in. We plug in our 5.43 meters per second times the 3.2 seconds. That one of the seconds will cancel. And so what we end up with is, again, 17.4 meters per second. Now, not quite done. Now, this one's easy because I gave you the initial velocity was 0. If I give you a different initial velocity, that would change. So we know that 17.4 is equal to change in velocity. which is equal to the final velocity minus the initial velocity. We know the initial velocity is 0. Now, if it weren't 0, let's say it were 10 or something like that, we'd have to like plug in, like let's say it was 10, we'd have to plug in 10 there, and then we'd have to figure out what VF was. But in this case, since it's 0, we can just leave it that way. VF then is 17.4. So my final answer is 17.4. Don't forget units, meters per second. All right. And so that's how you do each type of those types of problems. All right. If you have any questions,